This is Rita Qawl, Director of Education at Challenger Center for Space Science Education. Today's guest is Dr. Alan Stern, live in our studio, and our subject is asteroids. Dr. Stern is a planetary scientist, a member of the Challenger Center Board of Directors, and the former Associate Administrator of NASA's Science Mission Directorate. He is the principal investigator of the New Horizons mission to Pluto. Thank you and welcome, Dr. Stern.
Hi.
Let's start with a definition. What are asteroids and where do they come from?
Well, asteroids are really easy to understand. They're rocky bodies in space. Most of them, they're all over the inner solar system, but they originate in a place called the asteroid belt, which is between the orbits of Mars and Jupiter.
And how are asteroids different from meteoroids?
Most meteoroids are actually ex-asteroids that simply came to the Earth and entered the atmosphere, and some strike the surface. Of course, meteoroids are typically smaller than asteroids that you see in space because there are many more small asteroids than big asteroids. And so those that get loose and come near the Earth's orbit are representative of that population, and therefore we tend to get pelted by the little ones. The impacts by the big ones are really rare.
Can you tell us more about why asteroids impact the Earth and other places in the solar system?
Yeah, and of course they do. You see those craters on the Moon and the ones on Mars and Venus and Mercury. And even when you look at pictures of asteroids, you see that asteroids strike one another. Things are really empty in space. And asteroids orbit far from each other, but they're moving around all the time, and their orbits can change, both due to the influence of passing planets and also due to forces from the sun's radiation, primarily the pressure of sunlight, which even though it's very small, can build up over time. And that can cause the asteroid orbits to become planet crossing, to get in the way of Earth or Mars or Venus or Mercury, or even Jupiter for that matter, and strike those planets or their satellites.
So when you say that asteroids are kind of far away from each other in the asteroid belt, it's not the asteroid belt that we know from Star Wars where you're dodging them and trying to get out of their way because they're all over the place, but they're more spread out than that.
That's right. And even though there are millions of asteroids that are, the size of a kilometer or larger, it's the case that there's so much volume out there that they're very dilute, they're very spread out. They're typically millions of miles apart from one another.
So when we send spacecraft out through the asteroid belt, we don't have to worry about...
No, I like to say, it's completely empty. That is why we call it space.
What are the major hazards to people, to our environment, of asteroids? I guess we're talking about the larger kind here that could impact our planet and cause, some doomsday scenario or some other major environmental damage.
Well, most asteroid impacts are just small things that come to the Earth every day that weigh tons or tens of tons, and they don't cause any real damage. They burn up in the atmosphere, they strike the ocean, they might even make a little crater. They're just not very harmful. But from time to time, a larger something will hit, like 1908 was a year in which there was a significant impact in a place called Tunguska in Asia, inside Russia, where an object perhaps a kilometer across made an airburst over a forest and wiped out many square miles of forest. And of course, if that had happened over a city, it would have been much worse for people. Those things happen every sort of 100 or few hundred years. And then very much more rarely, a really large asteroid, perhaps kilometers across, will strike the Earth and cause a global climate change, like the one 66 million years ago that ended life for the dinosaurs and many other kinds of species at that time.
How are we currently spotting and tracking asteroids in our solar system, looking ahead to what may happen in the future?
Well, in fact, NASA has a program in place that's looking for the most hazardous population of asteroids, called the near-Earth asteroids, and trying to find all the ones that could create a dinosaur-killing-like event. Those are all the asteroids that are a kilometer or larger in scale. In fact, NASA has a goal of finding 90% of those, and is right now just finishing that goal and beginning to look at even smaller asteroids that are called city busters, which strike more frequently, still not so often that you should look over your shoulder, but strike more frequently. And NASA leads the world in this kind of effort.
That's reassuring. But say they find one, and it's a near-Earth crossing, and they determine that this large asteroid is going to impact the Earth. Could we send a missile to destroy it?
Well, we certainly could if we have enough warning time. And of course, the goal of these searches is to find all the hazardous asteroids, plot out their orbits, and determine which ones, if any, might strike the Earth in the next 50 or 100 years. And we could send a missile after it if we have sufficient preparation time, but I wouldn't advise it, because a missile would probably just break it up into a bunch of things that would hit the Earth. There are better techniques for changing the orbit of the asteroid that would mitigate the hazard without creating secondary hazards that could be bad.
You want to tell us some ideas for safely deflecting an asteroid from a collision course with Earth?
Yeah, there are a couple that are worth pointing out. We could, of course, attach some sort of a fuel plant that makes a rocket fuel on the asteroid and pushes the asteroid to a slightly different orbit so it will miss. We could additionally even just change the reflectivity of the asteroid. If we had enough warning time, just the pressure of sunlight from a more or less reflective surface could make the difference. And the third way is to show up near this body in a sufficiently massive spacecraft that if we stay rendezvoused with it, the gravity of the spacecraft would tug on the asteroid a little bit and move it.
Is there anything that we can do better? Are there any ideas for improving NASA's near-Earth program?
Well, as I said, NASA's interested in looking at how to do the next step, which is to go from the hazardous kilometer-sized bodies in the near-Earth asteroid population to the bodies down as small as 140 meters across. But because there's so many more little ones than big ones, we're going from a problem of finding about 1,000-kilometer asteroids to something closer to 1 million objects 140 meters across. So it's a much bigger search that's required. And remember, it's not just that there are more of these, they're also fainter because they're smaller, they reflect less sunlight. And NASA has studied how to do this, and there's some pilot projects in place. And if this is something you're interested in, you might write to your congressman about it. You might encourage private foundations to get involved, and you might go to planetaria or observatories and learn more about it.
So is this something for amateur astronomers to think about?
It's getting harder because all the easy ones have been found. And so amateurs typically now search not for asteroids so much as for comets.
So should we be worrying about an asteroid impact in the near future?
I don't think you should worry in the sense of lose sleep at night or wring your hands. But I do think it's prudent for NASA to continue the searches and to study mitigation techniques, to try to understand the physical nature of asteroids, to send missions to asteroids so that we know enough about them to spot any that may be hazardous, even if the hazard is 50 or 100 or 200 years off, and to learn enough about their nature as objects to be able to deflect their orbits when we find one that might someday be a risk.
Are there any plans for humans to visit asteroids? I've seen some popular science fiction movies that have humans mining asteroids, in the near future. Is that something that we've thought about?
We certainly have the capability to imagine how to do that. And in fact, there have been studies looking at how the Orion exploration architecture for the lunar outpost and transportation system back and forth to the moon could be used for human missions to asteroids. And that's certainly a nice halfway step as we gain experience after the moon en route to a project that would eventually send humans to Mars or other planets. And I'd look forward to seeing that someday.
Thank you so much. This is Rita Qawl, Director of Education for Challenger Center for Space Science Education. Dr. Stern has completed many other podcasts with us. For more about our podcasts, visit our website, www.challenger.org. And for more information about asteroids, you can visit www.nasa.gov.